Hello, this is the video for Flashback Friday, question 1, and it is a vectors question. So part A looks quite straightforward. We're going to find the value of k to make this the midpoint of these two vectors. So if A is 1, 2 and C is 7, 4, and we need D to be halfway between those, you can see already that K is going to be halfway between 2 and 4, so it's fairly easy to just see that K equals 3, so just one mark for that one. And then in part B we need the modulus of A to D, or the length of the line from A to D, to equal root 13. So the length of the line from A to D, well, A to D is going to be the vector the vector D minus A, which is going to be 4, so it's 4k minus 1, 2, so that's going to give us 3k minus 2 is vector A to D, and we need that to, so we need the modulus of that, the length of that vector, to equal root 13. So if we use Pythagoras for this vector here, we're going to get 3 squared plus k minus 2 squared has to equal, well, the square root of that has to equal root 13. So we can get rid of the square roots, and we'll just have 9 plus k minus 2 squared equals 13. So k minus 2 squared equals 4. And just make some room down here. So that would mean that k minus 2 is plus or minus 2. So k is going to equal 0 or k equals 4. So that's the answer to part B. And in part C, we've got to find one value of k for which the 4 points form a trapezium. So in order to get a trapezium for part C, you need one pair of parallel lines, or vectors in this case. We could have, there's lots of different answers to this, by the way. So we could have AC is parallel to BD. Okay, so AC, the vector A to C is going to be 6, 2, just subtracting these two vectors, you're going to get 6, 2 is the vector A to C. The vector B to D is going to be this minus this, so that's 1, and then k minus 5. And so if we need these to have the same gradient, because we need these two lines to be parallel. Okay, so for these to be parallel, we need the same gradient. Okay, so the gradient of AC, the gradient of AC, so the gradient of this is 2 over 6, which is obviously a third. The gradient of this is k minus 5 over 1, and so we've got 1/3 equals k minus 5. And just move down a bit. So that means that k would equal 5 1/3, which is 16 over 3. So that's one possible solution. That would give you one set of parallel lines, which means it's a trapezium. There are other possible answers to this. You might have done this a different way. Looking at the mark scheme, there are 2 other possible solutions. So the 2 other solutions to this are k equals minus a half and k equals 5/4. So any of these three answers is correct for this question.